button in the middle. It starts recording.
I'm not very good at that.
I'm great.
Well, I already hit it for you, so you don't have to do that. And then you just have to point this camera at whatever I'm doing. You can zoom in and zoom out by going up and down, those things. Think you can handle that?
I don't think I'm going to do it very well.
Well, just do it as good as you can. That's all we can ask of you. Okay? You can mostly have it on the screen, but if I'm writing something, you can turn it to that.
I can't fix
Does that make
it. I'm sorry. I'm not good with stuff.
Okay, you want to let somebody else try it?
Yeah.
Someone else want to try it? You want to do it? It's like running a
Sweet. Is it going?
going.
Oh, hey guys.
Can you see me? Can you see me on the other side?
Uh-huh.
Yeah.
This is my boy, Adam. This is Bolake. All right.
Okay. So let's get on to the screen here. If you can get it.
I'll figure it out.
So if there's a little knob there.
All right.
If you loosen it, you can move it. There you go.
Okay. You're like.
Make sense?
I'm just trying to get it right.
They're gonna be like laughing.
Should I look at the PowerPoint?
Yeah,
Or
you
like
can look
my
at the PowerPoint.
computer? Or okay.
Okay, so yesterday we talked about the atom. What's that in the middle of the atom? What's that called?
Nucleus.
It's a nucleus. What's the nucleus have in it?
Protons and neutrons.
Protons and neutrons. What charge are the protons?
Positive.
What charge are the neutrons?
Neutral.
What charge are the electrons?
Negative.
The electrons go around the nucleus in the electron cloud. That's all stuff we did yesterday. Y'all good with all that?
Yes, sir.
Do y'all remember the first electron level holds 2 electrons, and the next electron level can hold 8 electrons? Did we talk about that?
Yes.
You also talked about how the third one can hold 8 or more.
Third one can hold at least 8 and much more.
Wait, the second one can hold 8 or
8.
like 6?
8. In this case, it only has 6, but it could hold 2 more if it had 2 more.
Okay.
Does that make sense? Awesome. How we do? We good on atoms so far?
Yep.
Adam.
Now, sometimes atoms are called isotopes. You ever heard that word before?
Yes.
Isotope. Isotopes are atoms that have the same number of protons but different numbers of neutrons. For instance, protium has 1 proton, no neutrons. Deuterium has 1 proton, 1 neutron, and tritium has 1 proton, 2 neutrons. They're all hydrogen. Protium is hydrogen that has no neutrons. Deuterium is hydrogen that has 1 neutron, and tritium is hydrogen that has 2 neutrons. Those are called isotopes.
That means
You need,
if you
okay,
were
Lucy, you need to tighten it.
I did, and it
if it was
just
like a different
spelled.
atom, or like,
Alright,
what if it was plutonium and then you had more neutrons?
Well, plutonium has a lot more protons. So plutonium has, I think, 93 protons or something like that, maybe more.
Okay, got another mechanic.
Let's look at that periodic table. Where's plutonium?
Okay.
94. So
Oh my god.
there it is. It has 94 protons.
Lucy, sure you don't want to do it?
Its weight is down here at the bottom.
I'm on
It's probably got something like 98 neutrons. But plutonium could also have 99 neutrons or 100 neutrons. And then it would be an isotope. It would be
So,
isotope.
would the change name like it did for hydrogen?
I don't think so. I think it's just hydrogen has those special names. Yeah. It's kind of weird. You know what they use tritium in? Nuclear bombs.
Oh boy.
You ever heard of tritium before? See that big bomb right there? That's a hydrogen bomb. They call it a hydrogen bomb because it has hydrogen in the middle of it. And they can blow it up and make a big explosion because tritium, this form of hydrogen, is radioactive. And the nucleus will come apart really easily. Those neutrons will come flying off the nucleus and a lot of energy comes out.
Where is that explosion?
This is so
That was the
fun.
Bikini Atoll in the Pacific Ocean. And after World War II, they had a bunch of ships that they had captured, and they wanted to see if they set off a nuclear bomb, if it would destroy those ships. So they put ships at different distances from the bomb. And it did destroy a lot of them, and it didn't destroy some that were further away. Isn't that cool? They're nuclear fusion bombs. If you want to learn about nuclear fusion, you can study, take astronomy. We talk about nuclear fusion in astronomy. You interested in astronomy?
Yes.
Study the stars. Nuclear fusion with hydrogen is happening at the middle of the sun. It's happening right now. That's why the sun is glowing. It's like a million nuclear bombs going off in the middle of the sun every second.
Pretty funny.
Crazy.
Hey, foosball players.
All right. Here's 3 other isotopes that you may have heard of before. Carbon-12, carbon-13, and carbon-14. Carbon-12 has 6 protons and 6 neutrons. That's why they call it carbon-12. Carbon-13 has 6 protons and 7 neutrons. And carbon-14 has 6 protons and 8 neutrons.
So that's what the numbers are.
That's what the numbers mean.
Numbers.
Carbon-14 is radioactive. That means its nucleus tends to fly apart pretty easily. And every one of us has a little bit of carbon-14 in our bones and in our organic molecules.
QB.
You are made of mostly carbon. Did you know that? Not all of your atoms, but a lot of them are carbon atoms, and a few of those are carbon-14 atoms. So you're slightly radioactive. Go home and tell your folks, I'm slightly radioactive. Just wanted to let you know. Yeah.
Is there a limit to how many protons can be in one atom?
Yeah. Back to the periodic table. So the biggest one you see on this list has, how many is that? Can you read that number?
118.
118. That's as many protons as they can have in a nucleus. After that, the atom they won't stick together anymore. They just come apart. So that's the biggest one they've ever found. Now they think if they put enough energy in, they might be able to make nuclei bigger than that. But it takes more energy smashing these atoms together to make them stick together. And the big colliders that they've made don't have enough energy to make bigger elements. Every one you see here that's bigger than 92 and above is a man-made element. It's not naturally occurring. It's made in experiments. Isn't that interesting? You don't find plutonium except in a nuclear reactor. That's made by people. Yeah.
So that's why 6 of those, the ununtrium, palladium,
Yeah.
etc. That's why they're not named at all. They haven't been made yet. But
No. Oh, have they not been made yet?
Maybe they
Are you sure about
They
that?
haven't been
I think at a time period they stopped naming them and introduced a system for naming. Well, I'm not positive. Maybe they haven't been made yet, but I'm thinking that's just when they introduced the naming system, and so every element from now on goes by this naming system.
yeah, but there won't be any more.
There might be.
Well, there might be if they can get enough energy to stick some atoms together. Oh, by the way, they can use carbon-14 radiation to tell how old a fossil is. Have you ever heard of carbon dating?
Yes, yes.
If they find a bone, a skull or something buried somewhere, they can test it and see how much radiation is coming off of it. The older it is, the less radiation will be coming off of it, because the carbon-14 is a radioactive nucleus, and it'll come apart and release radiation. And after it does that, it's no longer radioactive. So the older it is, the less radiation it will be releasing. So if they find an old fossil, they can carbon date it and see how old it is by how much radiation it's giving.
I'm actually learning about like fossils that
Good one,
well,
Sam.
kind of like old human
Yes,
and
Sam.
history.
In history, yeah, ancient humans, yeah. They found through carbon dating that the first humans were around about 100,000 years ago. And maybe 200,000 years ago. the first humans that looked like us. Now have you ever heard of Neanderthals?
We're literally just
and
talking about
Homo erectus and Homo habilis. They were upright walking primates, but they didn't look quite like us.
I saw a video of an orangutan tying a knot and making himself a hammock.
Cool.
No, this is the third one.
What did he say?
Here they've injected radioactive isotopes into this person's body, and the thyroid gland will absorb the radioactive isotopes, and then you can see the thyroid gland on a PET scanner.
It looks like a butterfly.
It does. It looks like a butterfly. Yeah. This is called the PET scan technique, and it's another use of radioactive isotopes. You want to see video footage?
Sure.
Alright.
Check this out.
The positron emission tomography, or PET scanner,
I don't think
allows
they
the
can see
physician
it.
to see blood flow to an area such as the brain. The image is formed by the tracking of radioactive isotopes that are introduced into the bloodstream. Computers create an image of the body tissue, converting the energy emitted by the isotopes into a colorful map of activity. A PET scan can be used to diagnose any abnormal physiological activity.
See, if they think you got a brain tumor or something, they can shoot you up with radioactive isotopes, and those will go through your body, and some will go to your brain, and then the radiation comes out of you. It goes right through your skull and right out in the machine that she was laying in will read the radiation and can draw a picture of your brain without them having to cut your head open and look at your brain. Isn't that cool? Back in the old days, if they wanted to look in your brain, they had to cut your head open. Nowadays, you just get a shot and you lay in the machine. Yeah.
Isn't there a chance if you do use that machine that you could get cancer?
Yeah, they have studied what levels of radiation the body can tolerate, so they give you very low levels, so to try not to have that happen. Yeah. Okay, we want to study how. Question? Do you have a question?
Oh, I was just saying that. I think my mom does the thyroid stuff.
Does she really?
I think so.
Yeah. Ask her about that. Ask her if she uses a PET scanner.
What?
It's called a PET scanner. Ask her if she uses that. PET, PET scanner. It stands for positron emission tomography. Okay. Let's learn about how atoms bond to one another. How atoms stick together. There's two types of bonds you have to know.
Ionic.
Yes. And covalent. Y'all heard of this before?
We read it.
That is all we did last year.
This is all you did last year?
Well, and we read it in your like.
Because you read the assignment.
That's pretty good.
Blake.
Balake.
Here's how a covalent bond works.
I hope they can see.
Now, the water molecule, do you know the formula for water?
H2O.
H2O, baby. Why is it called H2O? Because there's two hydrogens and one oxygen.
Somebody wanna
And here's the deal. I should use a different color.
hit the angle? There's a glare. I don't think they can. There's like a glare on the whiteboard.
There's a glare on the whiteboard? Well, just do your best. It's okay.
Alright, they don't need to know this. Just kidding.
Maybe if you move the camera a little bit, maybe it...
Like, you want to take
Look
it?
and see if the glare disappears.
You're gonna hold it the whole time?
Does it disappear?
How do you zoom?
What if we do that?
Yeah, that's
Dude, why are you zooming in so much?
Maybe less glare?
This video, I feel bad for watching it.
Try not have it move too much so the people at home
Yeah,
can watch.
just keep it.
Okay, so, listen. One dot means the electron. Do you remember that hydrogen has one proton and one electron?
Yep.
How many electrons does hydrogen want to have a full outer level?
2.
It wants 2. It has 1. It wants 2. Now, oxygen is interesting. Oxygen has 6 in the outer level. If you count the outer level on the oxygen atom up there, you can see it has 6. 1, 2, 3, 4, 5, 6. If the oxygen shares with the hydrogen, you form what's called a covalent bond. The hydrogen goes in real close and moves in real close, and now the hydrogen and the oxygen are sharing a pair of electrons. We call that a covalent bond. The oxygen and hydrogen get real close. Now the hydrogen has 2 electrons because it's sharing one with the oxygen. So the hydrogen is happy now. Yay! And this hydrogen can do the same thing. It can come real close and share its electron. And now we have 2 hydrogens sharing with the oxygen. Now the oxygen has 2, 4, 6, 8 in its outer level, and it has a full outer level. This is what atoms want, to have a full outer level of electrons, and they do it by sharing electrons. Yes?
But if they're both gases, how do they make a liquid?
That's a good question. The water has the property, because it can bond easily, it's actually the sharing of this electron pair is not equal. Oxygen kind of hogs the electrons towards it, and because of that, hydrogen takes on a partially positive charge, and oxygen takes on a partially negative charge. We call it a polar covalent bond.
And that's why water usually sticks.
And water will stick to surfaces, and it will stick to one another, and that makes it a liquid. It makes it where it doesn't want to float around on its own, but it'll stick to things and kind of stay together. That makes it a liquid. Make sense?
Yep.
So one more. Let's talk about sharing covalent bonds again. Britton, hold this pen. Pretend Britton's a hydrogen and I'm a hydrogen. We each have 1 electron. This is the electron. How can we have 2 electrons? We just get real close, and you grab this one, and I'll grab this one. Now we each have 2, because we're sharing. And guess what? It's going to be hard to separate us, isn't it? You can't pull us apart. We're happy like this. See? We want to stay together. And you really have to put a lot of energy to tear us apart. So that means, thank you. So that means 2 hydrogens will bond to one another and share their electrons and make a gas called, have you ever heard of this gas?
No.
H2, hydrogen gas?
Yeah.
Never heard of hydrogen? Common gas. They used to put it in blimps. There's the hydrogen right there, hydrogen gas. You ever heard of the Hindenburg? It was a big blimp filled with hydrogen gas, and it blew up. Because the bad thing about hydrogen gas is it's flammable. If you put oxygen around, the hydrogen will break apart and attach to the oxygen. And when you break that bond, you release a lot of energy, and you can get an explosion. That's what happened to the Hindenburg. Have y'all ever seen the video of the Hindenburg going down? There's a guy that yells, "Oh, the humanity." Have you ever heard that term, "Oh, the humanity"? That's from when the Hindenburg went down. It was one of the first accidents filmed, because it was early in the development of cameras.
So it was just like...
Look it up on the internet sometime. Yeah.
So what caused it? Could have been just like a little static?
Yes, a little flame, they think. They think they dropped a rope from the blimp, and it rubbed against the ground, and they think some static electricity shot up and caught the blimp on fire. There's also conspiracy theories like terrorists did it or something like that. But they think it was probably just static electricity. So because of that, they stopped filling blimps with hydrogen. You know what they use now? Helium, which is also a light gas. It's not as light as hydrogen, but it does the job.
Aren't we like running out of helium in the world or something?
Yeah, it's harder and harder to find helium. I think they usually get it in caves and things like that.
Well, you can get a helium balloon.
That's interesting that you know that. Where'd you hear that? That's good. Good job. I like it.
I think I know why we're losing so much. All those balloons we see every day.
Yeah, those are filled with helium. There's oxygen. Oxygen shares 2 pairs of electrons. So if I was an oxygen and you were an oxygen, we would share 2. You ready? Let's share 2. You ready? Yeah, go either hand. Which hand? There you go. Okay. And then you got, yeah. So now we're sharing 2 pairs of electrons. That's a really strong bond. Okay, let go. So that's O2. That's the gas that you breathe. O2. You heard of O2 before?
Mm-hmm.
Look at this molecule, methane. It's a carbon. Carbon is a really cool atom, and studying biology, you got to know a lot about carbon. Carbon has 4 electrons in the outer level. You know how many carbon wants to have in the outer level? 8. 8.
Oh, 8.
It wants 8. So it can share with 4 different things. It could share with 4 hydrogens. It could share with other carbons. It can make these huge molecules because it has 4 in the outer level. That's why most living molecules have carbon in it, because they can make these giant structures. And there's methane. That's the simplest organic molecule, CH4, methane gas. Have you ever heard of natural gas?
Yeah.
They use natural gas to power a lot, make a lot of electricity and stuff. That's what natural gas is, methane. Yes.
Did you charge this? Because it's about to die.
It's running out of charge? Okay, just let it run until it runs out of charge.
Okay.
Sorry. Yeah.
What is C4?
C4 is that's an explosive, and that has carbon in it too. But it's a larger molecule. I'm not exactly sure. You could Google that though.
You think they can
Largest molecule?
I don't know. Maybe they can hear us.
You can get some that are just enormous, like DNA. You ever heard of that? That can be millions of atoms hooked together, billions even of atoms hooked together. So you can get some pretty huge molecules. Yeah. I don't know if there's one that's the largest of all. That's a good question. Let me talk about the other type of bond real quick. Sorry, people looking at home, if we run out of juice. You just have to read it.
Hey guys.
Sodium chloride, NaCl.
Is that ionic?
This is an ionic bonding substance. Sodium, Na, has, in its outer level, it has 1 electron in its outer level.
This is ionic.
This is an ionic bond. So if you look at sodium, it's up here on the screen. You see it has 2 electrons in the first. That's good. It's happy about that. It's got 8 in the second. It's happy about that. It's only got 1 in the third. If it loses that electron, it'll have a full outer level. So it really wants to get rid of that 1 electron and get rid of it. Chlorine has 7 in its outer level. It wants 1 more. So chlorine